Hi everyone, welcome to the new video. In today's session, we are going to speak about very important method used to solve inequalities, and the method is known as Wavy Curve method. Okay, so using this method, we can solve the inequalities. Okay, now this method is used to find out the nature of given inequality in particular interval, whether the behavior of that inequality is going to be positive or negative. Okay, let's say that, just giving you a rough idea of what it says. Let's say that we are given with the, let's say this is the case. Okay, so here we have, like, here I have -3, here I have -7. Now if I have to solve this inequality, now I have three intervals, so where the whole function is going to stay positive, negative. So using this method, we can determine where the function is going to be positive and where it is going to be negative. Okay, so this is what it says. The beauty of this method is that it is time saving. Okay, now we have different ways to solve this inequality, right? There is one more way that we have done in the past to solve inequalities. What we do, we just draw the number line, we put critical points on the number lines, and then we check for each interval, right? We check for each interval, we take any point that belongs to that particular interval, we put the value in the main function, and then we test the inequality, right? If it satisfies, then we find the sign or solution of the inequality, right? So, but the problem with that is that that is very time consuming, but that is the basic method, okay, how uh, it should be done, right? But you can also use this method if you are running out of time and you really need something fast to solve the question, then this thing comes to the rescue. Okay, so we'll discuss what it means, but here I want to say that I will take the example, and then with the help of example, I will show you what it means. Okay, so uh, let's say that we are given with this. This is of the type fx is greater than 0. Okay, so here I have assumed that this is f of x. Okay, this is function of x. Right now, see here, the given inequality, it can be of the form fx greater than 0. It can be of the form fx less than 0, or fx greater than equal to 0, or fx less than equal to 0. So you can apply wavy curve method on any of the inequality that you see. Okay, so it's not the case that it is just it is just applicable to one type. No, it solves all the inequality. Okay, so see here, first, when we apply wavy curve method, okay, we have to keep in our mind that this method is only applicable when your fx is of the type, when your fx is in the form of product of factors. See here it's in the form of product of factors. Here product of two factors, here product of two factors, here product of three factors. Here if you see, in numerator, we have product of factors. In denominator, we have products of factors too. Okay, so this is applicable when your fx, it represents the product of factors. Okay, or I can say that if your fx, it is of the type, x minus, it is of the type x minus a1 raised to the exponent k1, x minus a2 raised to the exponent k2, so on, x minus a n minus 1 raised to the exponent k n minus 1, and here x minus a n raised to the exponent k n. Okay, so this is nothing, it is just I have represented fx as the product of factors. Okay, here I have said that if I have n factors, then how the factors will look like. Here I have two factors, so um, I can represent these two factors as x minus a1 raised to the exponent k1, x minus a2 raised to the exponent k2, and then I know what's going to be the value of a1, what's going to be the value of a2. Here k1 is going to be 1, k2 is going to be 1. Okay, so I hope you understand it. And here just remember that here I'm saying for all k n belongs to z. Okay, means that the exponents, okay, the exponents that are mentioned here, it must be the integers. Okay, and your a1 is, it should be less than a2, should be less than a3, so on an, means that an, okay, an, it should be the greatest, right? Okay, so this is normal, right? Even here now, you can see here, if we have to rearrange it, right? Okay, so see here, here x minus 7, and it can be written as x minus of 3, right? So then we will get the points, then this will come here and this will come here, right? Now this will stay here. Why? Because yes, this will come here, right? So we have to rearrange. Okay, let's say that here I'm going to apply it here. Here our fx is x minus 7, and here x plus 3, right? So here what I can do is, here I can write it as x minus of minus 3, right? And here x minus 7, right? Now see here, I have arranged it in the form of x minus a1 raised to, now here I do not have any power, it means 1, 1. Okay, so x minus a1 and x minus a2. Here a1 is minus 3, here a2 is 7. Okay, I hope you understand it. So this is our first step, that we have to rearrange the factors. Okay, so here I can write rearranging factors to match the definition. Okay, definition, this is the definition, so we have to rearrange factors to match the definition. Okay, now what's going to be our second point? This is our step number 1. Okay, now step number 2 is that we have to draw the number line, and we have to represent these critical points on the number line. Okay, so what does it mean? So here, let's say this is my number line. Okay, so here I have 0, so here I have minus 3. Okay, so no need of this, and here I have 7. Okay, so now see here what I did, because here this is in the form of expressions, right? X minus of minus 3, right? So here, if I have to find out the critical point, or here I can say in terms of quadratic roots, so x equal to minus 3, it's going to be the root, right? So here, it's going to be the solution. Okay, because at this point, because see here, what I'm trying to say is that these are critical points, or I can also say that these are the terminal points, because here the value it's going to be 0, right? So here the function is terminating. That's why I say these are the terminal points. Okay, so -3 and 7, right? Now see here. So here my second step, it's going to be draw number line and 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 representing terminal points or critical points. Okay, terminal or critical points. Okay, terminal or critical points. Okay, I hope it is visible to you. Yes. Okay, now step number 3. Okay, step number 3 is that step number 3. Now see here. Now you can start from any end. Either you can start from extreme right or you can start from extreme left. So there is no particular rule which says that you have to stick to the extreme left or extreme right. You can start from anywhere. Okay, so let's say that in this case I will start from the extreme left. Okay, I can also start from the extreme right. Okay, fine. Okay, I will start from extreme right, right? Okay, so now see here. Now I will divide this whole number line in 3 intervals. I think you know this, right? Because here we are going to solve the inequality. So my first piece of number line, it's going to be this one. Okay, and my second piece is going to be this one. Okay, right, and the third one, it's going to be this one. Okay, represented by green. Now why I am doing all this, what wavy curve method will do here? Wavy curve method will tell me that what's going to be the nature of fx in these intervals. Is fx going to be positive here or negative here? If it's going to be positive here, negative here, and same here, right? So that's the main purpose why we are using wavy curve method, right? Because it will tell us how fx is going to behave in that particular interval. Okay, so now because I need one end to start with, so I can choose either the extreme left end or the extreme right end, right? So here what I have said that I will go with extreme right. So what I will do is number 3, my step number 3 is start with one end. Okay, start with one end. You can take extreme left or you can take extreme right. Here I'm taking extreme right. Now when I will take extreme left or extreme right end, then I have to take any value in that interval and I have to check how function is going to behave for that value in that particular interval. Okay, see here, this interval represents what this interval represents. Now see here, my function, see here, it says that x minus 7, x plus 3, okay, x minus 7 and x minus of minus 3, it is greater than 0. Okay, this is the given inequality, right? So what I did here, I am going to take any point now in this interval from it is greater than 0. Okay, so it means that I cannot include these points, so I am just using hollow dots. Okay, means these points are not included. I am taking this interval from 7 to infinity to start with. I need something to start with, so in this interval I took point 10 or the value 10, and I will see how this function is going to behave for value positive 10. Okay, so if I put 10 here, 10 minus 7, 10 minus 7 is 3, means positive, and here 10 plus 3 positive. So positive, positive means here the function is going to stay positive. I hope you understand. Okay, start with 1, and so here I got positive. Okay, so see here, start with 1 and uh, positive value for extreme extreme right. Okay, now once I got to know the behavior of that function in that particular interval, my work is done. Now it's very easy to me. Now see here, when I jump from this interval to this interval, what I will do, I will just look at the power of I will just look at the power of the expression x minus 7. If the power is odd, okay, if the power is odd, see here what I'm saying here, because I'm jumping now, this I know this interval here, the function is going to stay positive. Now I will jump from this interval to this interval. Okay, so on jumping from this interval to this interval, I have to check the 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 exponent, the power, sorry, the I have to check the exponent of this expression which involves 7. See here, this expression which involves 7. Okay, so here the exponent is odd. Okay, so if exponent is odd, then so number 4, I'm saying if exponent, now here I'm writing if exponent is odd, then the sign will change. Okay, sign change, and if exponent is even, then sign will remain the same. Okay, what does it mean? Now see here, when I will jump from this interval to this interval, so what is the boundary? The boundary is here at 7. So I have to check I have to check the exponent of the expression that involves 7. Here it is 1, and I know 1 is odd. So if the exponent is odd, okay, then here the sign will change. So here, if it is positive, here it's going to be negative. I hope you understand. Now, in this whole region from minus 3 to 7, the value of this function is going to be negative. Okay, if you don't believe me, you can take any number. Okay, let's say 0. Okay, so you put here 0 minus 7, negative, and here 0 plus 3, positive, negative, positive, negative. Okay, now when you move to the, now this interval, it's done, it's over, we have solved it. Now when you jump from here to here, then you have to check the exponent of the expression that involves minus 3. So see here, this one, minus 3, right? It involves minus 3. So look at the exponent. Exponent is 1, which is again odd. So when your exponent is odd, then your sign will change. So here it's going to be here negative. So here it's going to be positive. Okay, so positive, negative, positive. Understand? So I hope you understand this. Why? Because when we moved from this interval to this interval, we have checked for the exponent of the expression that involves minus 3. Here the exponent is 1. So when the exponent is odd, the sign will change. So here this will become positive. Now come back to the question, what it says. Here it says fx is greater than 0. Fx is greater than 0. Now look at this, where your fx is 0. sorry, where your fx is greater than 0. So here it's positive, okay, and here it's positive. Okay, so what does it mean? I can take the union of these intervals, so it will be, so your x will belong to minus infinity to minus 3 union 7 to infinity. Okay, so this is how you have to solve it. Okay, this is how you have to solve it. Okay, so this is going to be your final answer. Okay, so there is nothing, just first thing what you have to do is that you have to understand the definition, okay, and then you have to rearrange your expression in the form of in the form of what we have studied in definition, right? Then draw a number line, mention the terminal or critical points on the number line, right? Then you can start from the extreme right or extreme left. It's all up to you. Now, if I start from extreme left, the procedure is the same. I will test for any value that's going to be in this interval. When I jump from this to next interval, I will look for the exponent of the expression that involves minus 3. Okay, so see here, it's minus 3. Again the sign will change. Okay, when I will jump from second interval to third interval, I will look for the exponent of the expression that involves 7. Again 1, so sign will change. So it's up to you. You can go, you can start with extreme left or extreme right, but in the end you are going to get the same answer. Okay, so then you know that when your exponent is odd, then how it's going to affect the sign. Okay, so very easy. Okay, now we'll move to the next question and you will have more clarity on it. Okay, so question number 2 says, sorry, for this one the answer was your x belongs to minus infinity to minus 3 union 7 to infinity. Okay, now come to question number 2. Here the given question is fx less than equal to 0. Okay, now I have to uh, rearrange the expression if needed, right? I have to rearrange this function if needed. So, okay, here it says x plus 2, here x plus 8 less than equal to 0. This is already in the, this is already rearranged. Why? Because here I have 2, here 8. Okay, so I know that 8 is greater than 2, right? So here we are not given, I mean, here the powers are not mentioned. So I know it is 1. Okay, so what's going to be my first step? I am just going to draw the number line, right? My first step, my these are already rearranged, right? So my first step is going to be how to represent these points. Now, see here, I can write these as x minus minus 2, right? And here, x minus minus 8 less than equal to 0. Okay, now which one is this is not rearranged. Okay, so here uh, I can say, here I can say x minus minus 8 and here x minus minus 2, right, less than equal to 0. Now I am going to represent it on the number line, right? So this is going to be the number line. This is minus 8. This is minus 2. Okay, so this was my step 1. Step 1. Here I am saying rearranged. Okay, so rearranged the expressions, okay, according to the definition, right? And number 2, step number 2, is my number line. Here I'm just mentioning number line and representing the critical or terminal points on the number line, because I will know where my function is terminating, because at these 2 points the value of this function is going to be 0, right? So here minus 8 minus 2. Okay, now my first step, it's going to be, next step it's going to be, I have to take one end, either extreme left or extreme right. So this time I will take this end. Okay, this time I will take this end. Okay, so my step 3, so it's just, I'm mentioning here extreme left, right? Extreme left. Now what I will do here is that I will take any value that lies in this interval. Okay, let's say I'm taking minus 10. Okay, if I put minus 10 here, so it's going to be minus 10 plus 2. Minus 10 plus 2, it's going to be negative, and then minus 10 plus 8. Minus 10 plus 8, again negative. So negative and negative, negative and negative, it's going to be positive. So it means that here my function, it's going to stay positive. Okay, and here it is less than equal to 0, so it means I have to include these points. So here I am using solid dots. Okay, solid dots, because I have to include these points. Okay, so here my function will stay negative, because I took minus 10. Minus 10 here is negative, here negative 2, so negative, negative, positive. Okay, now when I will switch, now see here extreme left, here the value stay positive, right? Here my function fx, it's going to be positive. Okay, positive. Now step 4, when you go to the next one, right? Step 4, when you go to the next interval. Now when you move to the next interval, you have to check the exponent of the expression that involves minus 8. So what's the power here? 1. The power is odd. If the power is odd, if your exponent is odd, then the sign will change. Means that here it's going to be negative, right? It's going to be negative, right? So here for this interval, minus 8 to 2, your fx, I would say second interval or middle interval. Okay, middle interval, your fx, it's going to be negative, because the power is odd. Now go to the next step, number 5. Step 5. Now go to the extreme right. Extreme right. What would happen? Now look for the exponent of the expression that involves minus 2. Minus 2, what's the value? 1. Again 1 is odd, so your sign will change. So here positive. Okay, so here your function is going to stay positive. Now I know here it is positive, here negative, here positive. So I have to find out all the x that satisfies this inequality, which says fx is less than equal to 0. Less than equal to 0. So it means that I have to look for all those points where this function is getting 0 or less than 0. It means this region where it is getting negative, and I have to include these 2 points to y, because it says less than equal to 0. Okay, so for your fx less than equal to 0, your x belongs to minus 8 to minus 2, closed interval. Why? Because I have to include these 2 points, right? Please have a look. Okay, it's very, very easy. Okay, now For the next two questions, I'm not going to explain every single step, but I'm going to explain the whole question. Okay? Because I think now there is nothing to explain. It's already very simple. I mean, I'm sure like now you have a good understanding of it. Okay? So we'll start with number 3. Okay, just give me a second. Okay, so the next number 3 says that. So here I can write minus 8 to, sorry, x belongs to minus 8 to minus 2. Okay. Next, number 3, it says that number 3 says that x plus 1, x minus 5, x plus 5, it is greater than 0. Okay, so I can rearrange it so that it looks better. Okay, so what I will do here, uh, here I will start with uh, x minus of minus 5, and here x minus of minus 1, here x minus 5 greater than equal to 0. This whole thing represents fx, right? Okay, and here the power is 1 1 1. Okay, so what I will do first, I will just draw the number line and I will represent all these terminal points on the number line. Okay, so here I have minus 5, here I have minus 1, and here I have 5. Okay, now see here, now I have several intervals here. This is one interval, second, third, fourth intervals. Okay, I can start with either extreme left or extreme right. Okay, so let's start with extreme right. Okay, so here I'm just writing here, here for this interval 5 to infinity. Okay, because I'm talking about this interval. Okay, this interval. Okay, this interval. So your fx, what's going to be the nature of fx? Okay, so you can take any value. Let's say you take 10. So 10 plus 1 positive, 10 minus 5 positive, 10 plus 15 positive. So positive, right? Positive, positive, and fx is positive. Okay, next is minus 1 to 5. Okay, now when you jump from this to this one, okay, now when you jump from this to from black to blue one, okay, so what will happen, you have to look for the exponent you have to look for the exponent which has 5 in the expression, right? So where I have 5 here, right? This one, right? So the power or exponent is 1, right? Which is odd. Odd means that sign will change. So here, negative. Okay, so right here, fx is negative. Okay, now jump to the next one. Next one is this. Okay, so what's in the next interval? Now see here, you have to look for the exponent which has minus 1 in the expression. Minus 1, this one, the power is again 1, means that sign will change, again positive. So here minus 5 to minus 1, so fx is positive. Okay, now go to the next one. So when you jump to the next one, this one, again I'm representing with black. Again, look for the exponent that has minus 5 in the expression, this one. So power is 1. It means that your sign will change, right? So here, this is minus infinity to minus 5. Here, fx is negative. Okay, negative. So it will change. Now, what the question says? The question says that we have to solve the inequality fx greater than 0. Okay, so tell me where it is greater than 0. It is greater than 0 here. In which region? Where x belongs to -5 to -1 union 5 to infinity. So your x belongs to -5 to -1 union 5 to infinity. Okay, so just have a look and try to observe the things. Union 5 to infinity, right? Okay, so I hope it makes sense. Now let's go to the next one. uh, Next one says that, next one here we have x minus 3 square x plus 5 cube x minus 7 raised to the exponent 7 divided by x minus 8 raised to the exponent 11 x plus 2 raised to the exponent 4 less than 0. Okay, now see here. So this is the given inequality, right? So here you can say that, because here I am not going to rearrange because it requires a lot of space. So here, but I'm going to do lots of things in my mind, but I'm going to represent here on the board. Okay, the final result. Okay, so let's see. Uh, Now, see here, first of all, I would like to highlight few things here is here uh, we have odd exponents and we have negative exponents. Okay, for let's say this is your uh, even, sorry, odd and even, right? Odd and even. So this is even, this is even. Okay, so I'm just going to put stars because no matter you are going to take positive or negative, so even will give you the positive values. Okay, so that's why I'm just high. So what I'm trying to say that what's going to make the change? Only these three expressions or factors, right? Because here they are just, even, right? So what I will do first, I will draw the number line. Okay, this is my number line and I will try to represent the critical points, right? So here uh, x minus 8. Okay, this is 8. Okay, here 8 is done. Here 7, this is your 7. Then 7, then I have 3, this is 3 here, right? And then -2 minus 5, right? So this is going to be -2 and this is going to be -5. Okay, you can check it if the points are represented correctly or not. Okay, so I think this is fine, right? uh, 1 2 3 4 5, 1 2 3 4 5, right? Now let's start with any end. Okay, first start with this end. Okay, if you take any value higher than 8, okay, because this is our this is, see here, from 8 to infinity. Okay, from 8 to infinity, if you take any value, let's say 10, so here I know it's going to be positive, but here positive, positive, right? Here positive, right? And here positive. So it's going to be positive, right? Positive, positive. Okay, why? Because see, 10 plus 5 positive, 10 minus 7 positive, 10 minus 8 positive, right? Now when you go to the next, when you jump to here, so you have to check for this, right? So the exponent here is 11. 11 is odd, so it means here it's going to be negative, right? Negative. Then if you jump from here to here, then you have to check for this. Here again it is odd. 7 is odd, so here positive. Okay, when you jump to the next, you have to check for here 3. 3. Now see here 3, it is even. Now here it is even, so it will remain the same, sign will remain the same, positive. Okay, now you are going to 2. Where is 2? This one again, even, positive, so it's going to be positive. Okay, next is minus 5. 5, where is 5? This one, odd, so it's going to be negative here. Okay, so 8 to infinity, positive, right? 7 to 8, 7 to 8, negative. 3 to 7, positive. Minus 2 to 3, positive. Minus 5 to minus 2, positive. Uh, and minus infinity to minus 5, negative. Okay, and what are we doing? We are doing fx less than 0. Okay, less than 0 means I need negative this and this, so I have to take the union of these two intervals. So here I can write my x belongs to minus infinity to minus 5 union 7 to 8. Okay, so I hope you understand it. Okay, so that's how now you can see, like this wavy curve method, so you can save a lot of time if you have a deep understanding of this method. Very easy to use. Now see here how many things I have written here. Very few. I mean, I can do lots of things in my mind, and just I have to draw number line, and then I have to take one, and then the things will happen for other end if I know power is positive or negative. Okay, so very easy method. So I mean, you can implement this method to solve inequality whenever you get chance or opportunity. Okay, so it's a very good thing to master this concept. Okay, I promise you, you will save your time, and the chances to make mistakes are very low if you have a mastery of this concept. Okay, so I hope you understand it, and next time we'll do more interesting things. Okay, so have a great time. Bye bye. Thank you very much.